We've got this deep problem in philosophy called the problem of universals, and we can motivate the problem and show it to you using one triangle. Take Thales' theorem. It says if you draw one triangle and inscribe it in a semicircle, it must be a right triangle. And you can prove this by drawing one triangle, doing some angle math, looking at the radii. So look at the radii here. C to A, C to B, C to D, those are all the same length. And because they're equal, you get two isosceles triangles, ACD and then CBD. And that forces the angle at the top to equal the sum of the other two. And that turns out to be 90 degrees. And the puzzle appears because the conclusion is a universal conclusion. It's not just about this particular triangle. It applies to any triangle in any semicircle. Plato gives us a tempting answer to this. He says it can't really be about the drawing. If you zoom in, the lines aren't straight, it doesn't look like a 90-degree angle, the angles aren't exact. And so Plato says, look, the proof isn't about this particular triangle. It's not about the one you see, it's about the perfect triangle. And so the diagram is sort of a reminder of that perfect triangle. This perfect triangle represents all triangles. But if that perfect triangle represents all triangles, it can't be isosceles, or equilateral for that matter, and it can't be scalene. But every triangle has to be isosceles, which includes equilateral triangles, or scalene. So does this universal triangle even exist? What are we even talking about? And if universals don't exist, is universal knowledge even possible? This is the problem of universals.